Hi everyone. If anyone is actually listening slash watching right now, we are going to learn about limits at infinity. I know it's exciting. Just to start you off with an example to explain the concept. I'd like you to try to solve y equals 5x plus 2 when x equals infinity. The answer is pretty simple. There's no solution. Why? Well, people who Lee refers to as my homies, thanks for the touch, Lee, because infinity is not a number, it's merely a concept. It's the concept of numbers as they boundlessly increase or decrease. You can't quantify it, and therefore it can't be plugged into an equation. However, you can solve the limit as x goes to infinity of 5x plus 2. Remember, the textbook definition of a limit is if f of x becomes arbitrarily close to a single number as x approaches c from either side, then the limit as x approaches c is L. The concept of infinity is representative of an infinitely large number, so while it cannot be reached, it is approached as numbers get larger. Boom. Yeah. That graph is going off to positive infinity as x increases and down to negative infinity as it decreases. Yeah, good stuff. Moving on. Basically what I just said, as the value of x increases, the graph approaches infinity. Therefore, the value f of x that the graph appears to move towards is the limit as x goes to infinity. So, well, first some rules of thumb. They will get more in depth with these rules later. But the limit as x goes to infinity of any constant number c over any exponential function x to the rth power equals 0, and similarly the limit as x goes to negative infinity of c, again any constant number, over x to the r is also 0. That'll be revisited in a moment, but here we have the graph of 3x squared over x squared plus 1. And as you can see, it has a horizontal tangent at y equals 3. It's not quite 3 on the graph, but bear with me. As x goes to infinity, f of x clearly gets slightly closer and closer to becoming 3, and the same exact thing happens as x goes to negative infinity. As they increase or decrease without bound, f of x approaches 3. Therefore, the limit as x goes to infinity is 3. It's pretty simple if you can graph it out. You just look at the graph, see where it appears to be heading as x increases or decreases in the event that you're looking for x as it goes to negative infinity. But when you can't use a graphing calculator like you did on the AP test, you're going to have to use these three pretty basic rules to find limits at infinity of rational functions. So when the degree of the numerator is less than the degree of the denominator, the limit as x goes to infinity of f of x is going to equal 0. There's no exception to this. Don't think twice. If you happen to see something where it's like x over x squared, the limit as x goes to infinity is immediately 0. If the degree of the degree of the numerator equals the degree of the denominator, then the limit as x goes to infinity of f of x is the ratio of the leading coefficients. So, for example, if you're looking at the function 2x squared over x squared, clearly the degrees are equal; they're each squared. The limit as x goes to infinity of 2x squared over x squared equals 2. Just divide the leading coefficient. It's not necessarily going to be the first number, it's going to be the one of the greatest power, by the same thing on the bottom, the coefficient of the number with the greatest power. And the final rule, if the degree of the numerator is greater than the degree of the denominator, just stop. The limit as x goes to infinity does not exist. If you try and find it, you are failing miserably. Please just do not try. And thanks for listening.